Hello students, welcome to EDUHUNT online video classes. In the previous session we have discussed the worksheet and now we are going to discuss another worksheet, that is 4A. The very first question is, if x and y are any two whole numbers, then x divided by y is always a whole number. In this type of questions already I discussed. In this type of questions, just to go through the examples, then you will get the accurate answer. Okay students, now x and y are two whole numbers, then x divided by y is, I am taking x is equal to 1, y is equal to 2. Okay, always a whole number. X by y is equal to 1 by 2. Is it 1 by 2? Is it whole number? No, this statement is wrong. Never be a whole number. If I take, for this one, if I take x is equal to 4, y is equal to 2, then x by y is equal to 4 by 2, that is 2. It is whole number in this case. That means never be a whole number. This is also wrong. May be a whole number, is not possible always. Is not possible always, this is wrong statement. May be a whole number. Here, see, in this case, this is a whole number. In this case, this is not a whole number. Here, another case is also there. What is that? If x is equal to 2, y is equal to 0, because 0 is whole number, that means x by y is equal to 2 by 0. It is not possible, that is undefined. But not always, only in this case only. Sometimes it is whole number, sometimes it is not whole number. Okay, that means we can write it may be a whole number. Okay, answer for this question is option C, may be a whole number. Okay students, let's move on to the next question. The predecessor of 0 in the set of whole numbers. What do you mean by predecessor? Predecessor means before number. Okay, before number. Before number. How do we get before number? By subtracting 1 from the given number, I get the before number. 0 in the set of whole numbers. Predecessor of 0, write the statement till here. The predecessor of 0, read the statement till 0. Predecessor of 0, 0 minus 1 is nothing but minus 1. Okay, predecessor of 0 is minus 1. But here the question is in the set of whole numbers. What do you mean by in the set of whole numbers? Set of whole numbers means W, represented by W, that is 0, 1, 2, 3 and so on. All are positive numbers and 0. See here, the predecessor of 0 is a negative number. Does this negative number present in whole numbers? Never. That means predecessor of 0 is possible, that is minus 1. Predecessor of 0 in the set of whole numbers is does not exist. Now answer for this question is does not exist. Did you understand students? Chalo, let's move on to the next one. Which of the following property is not valid in whole numbers? Okay, already we have discussed the properties, all properties. First property is closure property with respect to addition. What do you mean by closure property? Closure property is nothing but take with respect to addition. That means A plus B is equal to C. This is whole number, this is whole number, this also must be whole number. Then closure property with respect to addition is possible in whole numbers under this condition. Closure property with respect to multiplication. That means take example. 2 plus 3 is equal to 5. All are whole numbers, this is possible. Not valid. We have to check which is not valid. Second option, closure property with respect to multiplication. That means take A into B is equal to C, another whole number. That means 2 into 3 is equal to 6. All these are whole numbers. This is also possible, this is also possible. Now closure property with respect to subtraction. Take A minus B is equal to C. A is 2, B is 3. That is minus 1. Is it possible now? No. Why? Minus 1 is not present in whole numbers. That's why this is the correct answer for this question. This is the correct answer for this question. Commutative property with respect to addition, it's possible. Okay. Let's move on to the next question, students. In the set of whole numbers, the valid operation among the following is. Valid operation we have to check. That means in the likewise in the previous question we have to check each and every option here. Okay. See here 16 by 4. 4 ones are 4 fours are. Now answer is 4. Okay. Now 4 ones are 4 fours are 1 by 4. Both are same? Never. So that means this is the wrong option. 1 minus 7. Next option. 16 plus 2 is equal to 2 plus 16. This is 18. This is also 18. This is true. And 2 into minus 1 minus 2. And 1 into minus 2 minus 2. This is also true. And 1 minus 8 is minus 7. This is also true. But the question is in whole numbers. Is minus 7 present in whole numbers? No. Does this minus 2 present in whole numbers? No. That means these two options are wrong. Now the answer for this question is B. Let's move on to the next one. Multiplicative identity in whole numbers is. What do you mean by multiplicative identity and additive identity? What is additive identity? Additive identity. 0. Multiplicative identity. What is multiplicative identity in whole numbers? Obviously 1. This is a direct question. If you know the concept, directly you can take the answer. Okay, students. Let's move on to the next one. 2015 into 2016 into 2017 is equal to. Very easy question. See, students. This is nothing but associative property under multiplication. Associative property under multiplication. Check. Here 2015 into 2000, all are in multiplication only. Check where is multiplication everywhere. Here plus, wrong. Here into and plus, wrong. Here plus and into, wrong. Here into. That means option A is the correct answer. Directly we can write the answer for this question. No need to do anything. No need to do any calculation. Okay. Let's move on to the next question, students. The property related to the given operation. 2016 plus 0 and 0 plus 2016 is equal to 2016 in whole numbers. Directly we can see associative, that means 3 numbers should present. Distributive, not at all possible. And commutative property, identity. This is identity property because 0 is additive identity. In case in the place of 0 any other number is there, that is commutative property. Did you understand, students? In case in the place of 0 any other number is there, then that is commutative property. 0 is there, that's why this is identity property. Okay, students, let's move on to the next one. The true statement among the following is. The set of irrational numbers is finite. In this type of questions we have to check each and every option. We have to check each and every option of the question. Okay, students, the true statement among the following. Here we have to check true statement. In the previous questions we did false statements. Now it is given that true statement. Set of irrational numbers is finite. Set of irrational numbers. What are irrational numbers? Irrational numbers are nothing but the numbers which are not rational. The numbers which are not rational, those numbers are called irrational numbers. Okay, students. Now see, irrational numbers are denoted by Q dash. Okay, these are finite. No, irrational numbers are infinite. Okay, that means this statement is wrong statement. Next, set of whole numbers less than 100 is infinite. Less than 100 means set of whole numbers. There are how many whole numbers between 0 and 100? We can count. Okay, that means that is finite. This is also wrong statement. Set of whole numbers is infinite. Yes, set of whole numbers is infinite. Next statement, set of integers is not infinite. Not infinite means finite. Already we have discussed. That means this is finite. So integers is also not finite, that is infinite. That's why option C is the correct answer for this question. Let's move on to the next question, students. If P into X is equal to P, then the value of X is. If you multiply, here check P is equal to P, you are multiplying by X. Okay, then which number into original number is equal to original number? Already we have discussed 1. 1 into any number you take, that is original number only. 1 into 10, 10. 1 into 5, 5. 1 into minus 2, minus 2. Okay, when you multiply any number by 1, you will get the original number as a result. Now see, p into x is equal to p. That means x must be 1 only. Let's check the options. 0 by 1 not defined. 1 by 0 not defined. And 0 by 1, this is 0, no. And 1 by 1, this is right. Minus 1 by 1, minus 1. Okay, this is the right answer for this question. Let's move on to the next question, students. The subtraction is commutative in the set of whole numbers. The statement is subtraction in commutative. Is it true or false? Let's check with the example. Commutative. Commutative means take two numbers, that means a minus b is equal to b minus a. That is 2 minus 3 is equal to 3 minus 2. What is 2 minus 3? Minus 1. Minus 1 is equal to 1. Is it possible minus 1 is equal to 1? No. That means this is a false statement. Did you understand, students? In this type of questions, we have to check the options while taking the examples only. We will get the accurate answer. Okay, let's move on to the next one. 12 by 6 divided by 6 is a whole number, natural number, fraction and integer. Let's do this question. 12 divided by 6, this is in brackets, divided by 6. 6 ones are 6 twos are. Now 6 divided by 6. 2 ones are 2 threes are. That means 1 by 3. 1 by 3 is what? Whole number? No. Natural number? No. Integer? No. This is a fraction. Now answer for this question is 12 by 6 divided by 6 is a fraction. Let's move on to the next one. Multiplicative identity in the set of whole numbers. What is multiplicative identity? Multiplicative identity is nothing but 1. Additive identity is nothing but 0. Multiplicative identity in set of whole numbers is 1, that is option D. This is a direct question. Okay. Let's move on to the next one. If y into x is equal to y is equal to 0, then the value of x is y is equal to 0. Here write 0. Y is equal to 0. Okay, fine. Here x is equal to x. You take any value that becomes 0 only. Why? 0 into any number is equal to 0. 0 into any number. That means 0 into 500, 0. 0 into 5, 0. Take any number. That means check the options. 1 by 0, it is not possible. 0 by 1, 0. And 1 by 1, 1. Here in this case, see, in this case, I can put 1 because 0 into 1 is equal to 0. I can put 0. 0 into 0 is equal to 0. Here, in this case, x does not exist. Y does not exist. You can take any number. X is even though x is a variable, we can take any number. Okay, irrespective of the x value, that becomes 0 only. That means that is answer for this question is option D, that does not exist. Did you understand, students? Let's move on to the next one. 2016 by 4 is a. Okay, same model question we have done in the previous section. 2016 divided by 4 divided by 4. First cancel this one. 4 ones are 4 5s are 20, 4 4s are 16, 0. This is 504 by 4. Again 4 ones are 4, 10, 4 2s are 8, 24, 6. That is 126. 126 is nothing but, is it a decimal? No. Negative integer? No. Fraction? No. Whole number. So 126 is a whole number. That's why answer for this question is A. Let's move on to the next one. Okay, students. Multiplicative inverse in the set of whole numbers is multiplicative inverse. Okay. What do you mean by multiplicative inverse? If I take a number 2, I should multiply a number by a number. The result must be 1 only. Which number do I have to take here? 1 by 2 only. 2 ones are 2 ones are. Though Answer is equal to 1 is equal to 1. Therefore, multiplicative inverse of 2 is 1 by 2. Multiplicative inverse of A is equal to 1 by A. Multiplicative inverse of 1 by 5 is equal to 5. Multiplicative inverse of 2 by 3 is equal to 3 by 2. This is the concept. Remember students. Now multiplicative inverse in the set of whole numbers. Whole numbers. For example, if I take 2, multiplicative inverse of 2 is 1 by 2. This 1 by 2, is there any number like 1 by 2, 1 by 3, 1 by 4 in whole numbers? No. That's why answer for this question is does not exist. Okay students, let's move on to the next one. Okay students, did you understand the worksheet now? Yes sir. Here today we discussed worksheet 4A. Okay students, thank you for watching. In the next class we are going to discuss a few concepts and then solve worksheet. Until then, see you, take care, bye bye.